In this era of globalization, the development of technology has almost become a reference for the whole world. Technology has the biggest impact on this country. Therefore, we as millennials really get to learn and apply it in our daily lives in an effort to maximize the use of technological globalization. Assalamualaikum warahmatullahi wabarakatuh. Hello, we would like to introduce ourselves to you. I am SETIYA MUBAROK and I am HAMIDAH. We are from Manila, Madrasah Aliyah Negeri 1 of Lamongan. Here, we would like to present our innovation with the title LECONTE, Catfish Controlling System, Aeromonas hydrophila bacteria, control tool in IoT-based catfish cultivation as prevention of harvest failure in Lamongan Regency. Reporting from the 2020 fisheries service data, catfish production in Lamongan Regency reaches more than 4,000 tons per year. This is because catfish cultivation does not require a long time to harvest. Catfish cultivation in rural areas can be used as an alternative solution to reduce unemployment, so that it can reduce the rate of population urbanization. The indicator of success in fish farming is the health condition of the fish, which will affect the increase in production field. One of the diseases that catfish farmers fear is motile Aeromonas septicemia (MES), which is caused by Aeromonas hydrophila bacteria.
Until now, farmers can only find out which catfish are infected with Aeromonas hydrophila bacteria if there are catfish floating. Even though it is quite late, because it is likely that the bacteria have spread throughout the catfish farming area. The number of catfish harvests since being affected by bacteria has only obtained 1.5 quintals, while usually can be 2 to 3 times as much. Based on this problem, we innovated to make a control device for Aeromonas hydrophila bacteria in IoT-based catfish cultivation that makes it easier for pond farmers to detect and control the growth of Aeromonas hydrophila bacteria so that it does not harm farmers because it has been detected early.
From this background, we decided on three problem formulation, namely: the first, how to make LECONTE; second, how to test LECONTE based on its functionality; and the third, how effective is LECONTE. The ways in which research was included: first, indicator creation; second, making tools including tools and material tool assembly; fourth, tool testing; five, prepare LECONTE in the event of an error that does not go according to plan; six, LECONTE retest. Here is tool design from LECONTE, Catfish Controlling System.
The following is the design of the research flowchart display.
The figure shows the pH, salinity, hydrogen sulfide level, and ammonia level in the water. The temperature and TDS sensor use the DS18B20 analog TDS sensor. The pH sensor kit PG4502C. The hydrogen sulfide sensor uses the MQ13C, and the ammonia sensor uses the MQ135 sensor. Then, there is also an LCD which will later be connected to the ESP32 for processing. Furthermore, the ESP32 connection to the Node MCU uses serial communication to connect to each other, so that reading data can be sent to internet-based entry. The tool will operate when the on button on the tool is pressed. It will display the result of monitoring the water quality of the catfish pool. If the parameter is out of the predicted time range, the alarm will sound and it states that the catfish pond is attacked by Aeromonas hydrophila bacteria.
In making the program, the researchers uses Arduino 1.8.15 for coding, which includes variable identification, calibration of all sensors, setting the LED light according to the sensor condition, displaying sensor detection result to the LCD, each sensor working to read the pond environmental condition, setting and connect with Wi-Fi, and finally send the sensor data result to the LECONTE app for monitoring.
From the table, the levels of ammonia in natural water are usually less than 0.1 mg per liter. The level of free unionized ammonia and H3 in fresh water should not be more than 0.02 mg per liter. The optimal dissolved oxygen in the water is 3.5 to 6.1 mg per liter. If there is no oxygen in nitrate in the water, hydrogen sulfide H2S affect water parameter. The toxicity of H2S increases with decreasing pH value because a pH 5 sulfur is in the form of hydrogen sulfide H2S. The optimal pH for catfish growth is 7 to 9. The optimal temperature for catfish growth is between 27 to 30 degrees Celsius.
The conclusion of our research is, first, volumetric quantity begins with determining the indicator for each parameter, making a series of cameras, making programming, and finally compiling and calibrating the sensor. Second, liquidity testing includes calibration test and functionality test. The accuracy value of the calibration test for each sensor, for the pH sensor, for the ammonia sensor, for the hydrogen sulfate sensor, and for the TTS sensor. The accuracy value of each sensor is above 95%, so it can be said that the sensor map is quite accurate and has a high precision value. For functionality testing, its electronic component, pH sensor, TTS sensor, H2S sensor, and HD sensor, LCD, and LED are worked with an overall accuracy value of 98.78%. Third, it has a high effectiveness value. It is proven by the high value of accuracy in reading the stage of catfish point in either normal or abnormal point condition.
That's our presentation. We hope that our intention are convincing to the judges.
All problems come with solution. Growing economy, prosperous farmers. Wassalamualaikum warahmatullahi wabarakatuh.